Hey guys, this is Wayne here with Training County Locksmith Service. I'm with John from Reliance Security, and today we're going to be installing a door operator on this interior door at the library here. John's going to explain to us a little bit more about all the parts and pieces needed, because sometimes people don't think about what it actually takes to install an operator on this door. One of the biggest things we're going to have to contend with is right now, if I just try and push this door open, it's not going to work because this lock has it shut. Now this is just a passage lock. It doesn't really provide any security from this side. However, we do need to have an electronic strike that releases, so when you push the button, it's going to need to release the strike, tell the operator that the door can open, that way they don't fight each other. So John, tell us a little bit more about how we're going to put this together.
All right, so as we mentioned, we have this cylindrical prep door. So first thing we're going to need to do, get ourselves a strike. Okay.
Which is that? That's a Locksmith.
Yes, this is a Locksmith NC450.
Okay, NC450, awesome. So that's going to go in here, and that will work with a door that locks or that is passage, correct? We could put a credential on the outside, but we don't have to.
That's correct. So the main function is so that when the operator needs to operate, when you push the button, it unlocks the strike, and then the door opens for you. Now this door, while it is passage from the inside, has a classroom function on the outside. They do lock this room down, so when they lock that, they turn off the operator. Nobody can just come up, push the button, bypass the locking mechanism.
Perfect. What else are we going to need?
So what we're going to need is our 4040 XP, and in our 6440 kit, the closer comes with that. We get our module kit here. This is going to have all the bits and pieces we need for motor assembly. We have our cover kit here, so this includes the cover and a couple other pieces to cover all the pieces. And then we are going to use this power supply. It's a Von Duprin power supply, so everything's staying LCN. And what this has got in here, it's got a relay board, and that relay board is going to activate and power our strike.
Now, to clarify, if we didn't have all of the other moving parts to this, let's say we just had a regular interior door and maybe it had a deadbolt or something on it and it didn't have this latch here, and it was just open or unlocked for the day or locked for the day, either way, and we just wanted to mount the closer and the operator up here, and it comes with its own power supply, correct?
That's correct.
So
this does come with its own power supply. So if you are not using an electronic strike, then yes, it will automatically work.
So we're showing several different ways how to do this. This is the more complicated way, so we're going to show the more complicated way, how to make sure we tie everything in. So the operator talks to the strike, talks to the power supply, they all work together to make this opening work as a whole function. There are less advanced ways to set this up, where we could set it up to where it would just have the power supply on its own, correct?
That is correct, yes.
All right, very good.
So like on a bathroom door, that's where we'd see a really simple, obvious installation.
Okay, bathroom door would be a great example. Usually it's just going to have a little slide latch on the inside. When it's in use, then it's locked, and when it comes out, it's going to stay open. But there would be a button on the outside, so somebody that's handicapped would be able to come up and open that door and utilize the restroom.
Yes.
All right, perfect. So talk me through, when you're building this plan, what do you put together as far as building this plan out?
So I come in and take a look at the door. Now you can take pictures, we send you pictures, but really just coming out, evaluating, basically grabbing a hold of the door, figuring out how they want it to function. Since they want to lock this door down, we really can't remove the cylindrical prep off the door, which would make things 10 times easier. So instead we have to work around that. So it's just that, coming in, how easy is it? Do we already have a closer on here? Do we not have a closer on here? What is the duty on this door too? This is a pretty lightly used door. So light to medium usage is kind of what we're looking at, which fits very well for this operator. People that aren't handicapped are going to be able to come up, hold the handle open, nothing's going to break. So it's very simple for everyone to use on the door.
So the very first thing that we're going to look at, and that actually kind of skipped my mind, but I'm glad you brought it up. Door health is going to be the first thing we want to look at, whether the customer sends you a picture or, like you said, you touch it, feel it, get your hands on the door. Is it closing properly? Does it have hinge problems? Is it rusted out? Is this door a good candidate to have an automatic operator added to, because now we're going to add extra weight and extra parts to this door to make sure that it's going to be an automatic door. If we don't have a healthy opening, meaning the frame or the door is bad, then you're wasting your time dumping money into something that's not ready to accept that. Address your hinge issues, address your glass issues, address your frame issues, and then when you have a healthy opening, now we can put together a plan for a healthy door operator. What else are we going to, when you're putting together this plan, what parts and pieces do you start evaluating for this door?
So like you said, door health, very important. Are the hinges okay? All that stuff is excellent. And then it's really just how is the customer going to function with this door? Above here we have an exit sign, so we know this is a exit door. So in the case of an emergency, people are going to need to get out here, so we still have to have our single action egress. The other thing that exit sign tells me is that there's power right above here. So if we're setting this door up as a standard, just a regular, simple, plug in a wall transformer, hook up the door, I know that I can have my electrician come down, hook an outlet right up next to the door. In this case too, we're gonna mount the power supply right up here, because again, we have that advanced piece. We need more power than the standalone wall wart piece can give us. And so we're gonna mount this up here, they're gonna run the power down into it. I know that because I work with the electrician really well. So in my evaluation piece, I'm pulling everything that I need on this door to make it function first, address the power supply piece next, and then address how my electrician is going to come in and do my wiring for me.
So we're thinking several steps ahead, almost like a game of chess. If we need to have power brought here, we need to make sure that we have access to power, and our job is to make sure that the electrician's job is as easy as possible to bring us 120 volt power to that power supply, and our wire run needs to be as easy as possible. Just think, we're here at a library and we're actually donating this installation, the parts and materials, to this establishment, there's going to be a lot of kids and stuff in here, so we can't just run a wire over to an outlet where kids could touch it, get into it, things like that. We need to keep public health and safety in mind as well with this project. The way we're setting it up, everything's going to be up and out of reach, correct?
That is correct. So one of the other things too, we talked about the door health, and then we have this glass kit sitting here too. So this light kit, glass kit, whatever we want to call it, sits here in the middle of the door. Now we could mount a door closer here, we could put it in parallel mount. However, that's not going to help because the motor is going to come down into the glass piece. So the other piece we evaluate is, well, how else can we mount this thing on here? So we're going to mount this as a top jamb. So we're going to have a plate that sits up here to hold our closer, and then our operator mounts on top of that. So it's even more up out of the way, out of the public's eye, essentially.
Perfect. So the things that we're deciding is it going to be a push or a pull?
Right.
Is it going to be mounted parallel or parallel along with the door, or is it going to stick out?
Yep.
And then once we have that figured out, that'll give us the mounting for the actual closer. We're going to mount the closer on first, and then we'll add the operator to it. Okay?
That's right.
Cool. All right, let's get started. All right, so one last thing that we want to bring into the equation here, along with job preparation, John has some really good information about taking the parts in your plan that you draw out either in your head or put all the parts on paper, and then go ahead and check with the manufacturer. Tell us about how you do that.
So what I do is I work with Allegiant directly. I have a sales rep from them. He and I talk about a lot of different projects. So make friends with your manufacturer reps, make sure that they understand how the stuff's installed. If the manufacturer rep doesn't know, you can always reach out to the manufacturer's design team. Allegiant has an excellent form of building these projects. So they will even build a blueprint. You can take some measurements and they will actually set out a line drawing, like an architectural type drawing, if you really need it with wiring and everything else. Pay a small fee for that, and they actually design it for you. So if you're not sure about something, always run it by the manufacturer first. So we're not putting things on the door that don't need to be there, or we're not missing anything. A second set of eyes is always a great idea.
Yeah, I do it all the time. I forget one part or one piece, and then I run it by John. He runs it by the manufacturer. We figure out between the 3 or 4 of us that are involved exactly all the pieces, and nothing gets left behind. You're also going to want to remember that when you do work with the manufacturer, they're probably going to want to keep all of the pieces in-house or from that manufacturer. So you'll notice everything is going to be a Legion or LCN today. Everything from the closer to the power supply to the strike to the operator to the motor, everything we're going to be using is LCN product today, correct?
That is correct.
All right, very good. So we'll go ahead and get started with this and go from there. First things we want to show is that we tape off the area with construction cones and caution tape. Here we are showing John as most customers try and jump over the caution tape. Right now you can see that there's nothing actually controlling the door. It just stays open, flops around. So we're going to get this door under control, bringing it closed every time, and then installing the operator to go ahead and open it. You'll notice that we're protecting the public from our work area. This is a closed room. There's no other way to get in here. But out here, we've got caution tape and cones to keep the public from coming in. And even though you do this, you'll still have people climbing over cones and things to try and get into your work area. So try and make it as contained and safe as possible. Here you can see all of the parts laid out on this table so we can see them and install them. All right, so one of the first things we're going to be installing is this 4040 XP mounting plate. Go ahead and tell us about it and what we're going to do with it, John.
All right, so this is a top jam mounting plate. It's going to come right up top here. And once we get that mounted up, following our instructions here, it's going to give out some different measurements on how far this first hole needs to go. So these holes here, it's going to tell us how far from the hinge over this direction that first hole is going to need to go. We're going to line that up there, get this plate mounted up. We're going to mount our closer up here. Also, these instructions do tell us how far over the arm needs to be on the door. So when we're done here, the arm is going to come out at a 90 degree off the door and operate correctly.
Perfect. Now, one thing to remember is you always want to try and use as many of the screws and things that come with the hardware kits as possible, because this was tested at Underwriter Laboratories with these particular screws. So that means that we need to use these screws, not one from a random screw bucket, because they weren't tested in the actual UL listing. This one is actually going to give us self-tapping screws, probably those 6 self-tapping screws to go and actually hold the plate onto here.
That's correct.
And then it's going to have these other pre-machine mounted screws that are going to actually be exactly the length that you need so that it goes through the operator or through the door closer right to the plate and then ends flush. So you're really going to want to make sure that you keep track of this nut and bolt kit. In fact, if you start doing a bunch of these, I always recommend ordering an extra couple bolt kits. That way, if you get one that shows up and it doesn't have it, it gets lost in shipping, they didn't add it from the manufacturer, whatever, you're not going to be out of bolt kit. Always having extra bolts is never going to hurt anything.
Exactly.
Alrighty, so when we mount our mounting plate up here, what are our measurements going to be as far as over and then vertically up and down? And then what is the degree of opening that this closer is going to allow us to have?
So this closer, in the position we're about to mount it into, will allow 120 degrees open. The instructions tell us that we need to come over about 2 9/16 to this first hole here.
Okay.
And then down from the top of our jam here to the center line of this hole is about 11/16 is what that should be. There's another measurement for down here. It's really small, but basically we're going to take into consideration all those measurements and drill our holes right here.
Perfect. Now John is going to be marking the holes with an automatic center punch and taking that measurement. We want to pre-drill these. I always find it's easier to pre-drill, so the first thing we want to do is make sure that we've got the proper sized bit so that you don't over-drill and drill. So basically it just has to be one size smaller, or any size smaller than the tip of the actual self-tapping drill bit. Now John is using the high-speed steel drill bit to go ahead and pre-drill the holes that were made with the automatic punch. That automatic punch will allow the drill bit not to wander and for a precise hole to be drilled. John starts out by using the first hole as the alignment or measuring point. Here you can see that first screw installed, and then the other ones
with their holes drilled subsequently afterwards. Again, using that high-speed steel drill bit to pre-drill or pilot drill is going to make everything a whole lot easier for the rest of this project. Using the self-tapping screws offers opportunity to slip and scratch the work area. John is then also going to install the actual screws themselves.
Yeah. All right, so now we're going to take our measurement. The plate is mounted and fixed up top with the self-tapping screws that came with the kit. Now we are measuring for where the arm is actually going to meet the door. What are our measurements for that? 2.5 inches down?
2.5 inches down and 10 3/4 from the frame, from the edge of the jamb here over. So we're going to take our measurement, excluding our doorstop.
That's a very important thing to remember, is that not including the doorstop in this measurement is going to be very important. 10 3/4.
3/4 is going to bring us out to here, and then 2.5.
And 2.5 down.
We're going to be right around in here. So if we want to take 5/8 off of that, then we can get our measurement there.
So what we've done is actually subtracted the, what is it, 5/8?
Yep, take 5/8
off the door.
Really easy on our measuring tape here. We just go 3/4 and we just count over 1, 2, 3, 4, and 5/8 gives us this 1/8 inch mark here.
Okay, perfect.
This is going to show where we center punched for the arm to the door.
All right, so John's going to go ahead and pre-drill this hole. And then we're actually going to drill and tap this out to 1/4 by 20 so that we can use the supplied screws from the manufacturer. John's checking up a drill bit tap. This is one of those things that we use to help speed the process along. It will work on thin steel, but anything over probably 1/8 of an inch is going to be a little too thick in most cases, and then we'll break the tap. Beautiful. So thinner doors, yes. Thicker frames or double thick doors, probably not a good idea to use that particular tool. Now John's attaching the first screw of the arm. We'll go ahead and get a measurement and do the other side.
You'll notice that one of these is going to be kind of an oblong shape. So when we come over here, mark our hole. If we're off a little bit this direction, it's not going to matter as long as it's not more than about 1/8 inch or 1/2 inch.
Perfect. So it gives us some room for error.
Exactly.
Here you can see that self-tapping drill bit. These are from Greenlee, or Milwaukee also makes them. You can see what the hole looks like tapped in the door. Now John is going to be reinstalling that arm with the hand screwdriver and then the impact driver to snug everything down.
Alright, so as we're mounting up our closer, first thing you want to do with any of the LCN closers and with any closer is grab a hold of this screw back here and tighten it down.
if you're mounting it in a certain position or mounting it at all.
At all. So the, like a paint cute. So this particular screw, if it's not mounted in here, you know, screwed all the way in, the closer is not going to work correctly. It ships with the valve open, so the fluid has time to settle out, do whatever it's going to do inside of here, and you crank this sucker down until it's tight. You don't back it off a little bit, crank it in all the way until it's tight.
Perfect.
The valves on the front, just leave those alone.
Okay, and then there is a little bit of stimpling in them. Some of the older ones may not have had that, but this is designed so that you can't back the, or at least it gives you some resistance if you try and back that out too far before it comes out and sprays oil all over your work area, and then you have a really bad day.
So earlier Wayne was talking about these special screws. When they go into the closer, you can see they stick out just a little bit here. It's about the thickness of this plate. So
that is a nice feature of using the template or the mounting plate like so, is that it's going to give you a better, more secure mount, and it's already going to have a perfect footprint for you to mount the closer directly to it. So we talked about having an extra bolt kit earlier. We're already running into one of those issues where there should be a screw with a washer on it in here to attach the arm to, but it would normally be a Phillips head coming from this pack, right?
that is correct.
So this is going to be the one out of our operator. We're lucky enough that we still get to have this screw. It's still going to work for our application and go where it's supposed to go. However, if we didn't have this operator kit, we wouldn't have that screw in the screw pack. So ordering extra screw packs is definitely going to help save the day.
That's correct. And this particular bolt, when you read through all of your instructions before you do any kind of work, which is very important, understand every step you're doing. This operating instruction here tells us that we have to use this particular setup on the closer in order for it to meet its UL certification for safety.
Beautiful. Now this is the arm mounting bolt, arm position mounting bolt. Now that the closer is actually installed, John's going to give us some information on how to adjust it properly.
All right, so the 3 adjustment screws here are going to be our back check, and then we're going to have the closing speed and latching speed. So the back check is as you open the door, as it comes to its full open on an exterior door especially, it's very important that that be set so that if the wind catches the door, it slows it down from being able to open really quickly. In this application, there's a door stop back over here, and there's a small amount of back check, which is fine. From a 90-degree position, we're going to want to count and make sure that our door comes from that 90-degree position to a full close within about 7 seconds. But
that was right at 7 seconds.
Excellent.
Cool. All right, so we didn't have to do a lot of adjustments on this one. However, if you did need to do your adjustments here will take care of that. They can slow the latch down, speed it up, the back check, and the door sweep all in the same area.
All right, so the next portion here is to take this bracket.
Now that the closer is fully installed and adjusted properly.
Yep, we're going to take this bracket, and you'll notice some Loctite on the bracket here.
Let's get close up to that. Okay.
Okay, and that Loctite's going to hold our screws in. You're going to torque these down. Nice and tight. Don't over torque them. Don't strip anything out because that'll give you a bad day. You got to replace the closer at that point. So you're going to torque these down nice and tight. So if we were mounting this where the motor comes underneath, there would be an armored cable that comes down. However, since we're mounting a top jamb here, we don't need the armored cable. So we're gonna pop this thing here.
That little socket looking piece goes over the square stud.
Yeah, so on your closer, you're gonna have a stud coming out the top, stud coming out the bottom. This little socket looking piece here does go over the top of the stud here. And like you saw me here, you're probably gonna have to wiggle this thing around a little bit to get good contact. And then you're gonna wanna line the top holes here with these holes here. Just a second ago I talked about this little piece here. If you're mounting this thing down, this kit comes with this nice door loop. So if you're coming from the device over to the frame, this is the door loop kit you would use. And this little piece here just kind of fits inside of the arm here. So it looks about like so. But we're not coming from a loop down here and going over, because it actually attaches up top here, so that's kind of weird. So instead what we're going to do is our wires and everything are going to run along the top of our jamb here or inside the wall or inside the jamb. So it's going to conceal the wires and protect them inside there. So our screws again with our
Red Loctite.
Yep. So now we're going to torque these into this upper plate here.
Be careful doing it with your impact drivers. You can strip and break things. It's best to do them by hand, but we can do them with the impact drivers as long as they're on a very light setting and you're paying attention.
There is also a torque specifications. It has to be over a certain number of foot-pounds. It's not very much, but the impact driver will pull that down to the proper torque value. So you're gonna read the instructions and find out what that torque value is for your application.
Foot-pounds or inch-pounds? Much torque?
So it is 30 inch-pounds here in the instructions.
30 inch-pounds of torque, or no, 30, okay. Oh.
30 pounds inch minimum.
Okay. So now we're going to be planning out where we're going to put our power supply. We need to keep in mind the straightest power runs or the straightest wire runs are going to be the best ones to have. The less obstacles and corners and turns that we need to make, the better. So tell us how we're going to mount this, John.
So we're going to take this power supply and we're going to mount it like so. We're going to keep it in line with the jamb here as much as possible, make this a little bit more symmetrical installation. And behind the power supply on this corner, we're actually going to drill a hole from up here at an angle to go inside the jamb. Because there's a cavity inside of here that we're interested on the other side to run our wire through for our door strike. So once we get that hole situated that direction, we'll also be able to use this same hole to then come through the header here and actually come out here where we drilled a hole for wires to run over to our operator.
So this is going to make sure that the wires all stay hidden either in the frame, behind the wall, in the power supply, or hooked up directly to the strike or to the operator, and we only have two directions to go. We're also setting this up so that we know we have power up above. Electrician can drop power in behind the wall, tie it right in, and everything's going to work. Because we have so many pieces, we have to make sure that our plan integrates the quickest, smoothest wire run to all the components, including original 120 power.
All right, so we're going to put in our no-cut strike here. So first we're going to take off our strike plate.
No cut strike means exactly that. Little
We
to...
don't have to cut a giant hole out of here.
Yeah.
Exactly.
Cool.
So, while our strike will fit in here just fine, we have this pigtail. And this tail here has to go up inside the frame. And some of these boxes are a lot shallower than this one. This one, it looks like we can slide our strike in with without having to cut that box out, which is amazing. We might just have to notch a little bit right here.
For that dead latch.
For our dead latch, yes.
Perfect. Cool.
Our hole,
You basically, there's a dust box in there, right?
Yep.
So he's drilling through the dust box up into the channel of the frame. That's all it takes. And it's pretty standard that a 1/2 inch hole will be sufficient enough to get that wire block through, right?
Typically. And that is the case.
Beautiful. No cut strike. Again, normally you'd have to cut way out here and all this other stuff. That's what this strike is really, really nice for.
Here I'm showing that I've got some forceps. These are excellent tools to have. I've got a very large array or a couple different styles, sizes, and shapes of forceps. When you're pulling wire, these are absolutely essential to have. Long needle nose pliers and long hemostats are going to be your best friend. So now you can see I'm at the top of the jam, and John is fishing the fish tape up to me along the frame line so that it's completely concealed and hidden. And then I grab the fish tape as soon as I can see it. I'm basically looking down in there with a flashlight and those pliers and pulling it out.
So you can see that we've got the fish tape, comes into the strike hole, up into the frame, and out here. All right, now we're going to pull the wire down. Wire's going to come in through the hole.
Maybe.
Electrical tape has attached the wire to the fish tape. What type of wire do we have, John?
This is some 18-2.
18-2?
18-2
Shielded,
stranded.
non-shielded?
Unshielded wire.
Unshielded wire. There. Can you pull? There it goes. And if done correctly, it actually feeds right out of the box.
So now what we're going to do, we have all of our pieces in place. We know what we're going to run our wire and all this stuff. Now we have to figure out how we're going to wire this thing all together. So we have a few different pieces here. We have our strike, and our strike does have the option for 24 or 12 volt. These two pigtails are very important for wiring for 12 volt. We're going to use this one. 24 volt, we're going to use this one. Notice the DC, do not hook AC up to these. All right, that's just one piece. Now we have our operator and we have our power supply. We also have some other information about our main board on our power supply. I'm not really worried about that. We have a subboard on here though. And when we look inside the power supply here, this is the main power supply. This is where main power comes from here. And you notice this little jumper cable over here to this subboard. This subboard is really important because it's got some relays and it has a little bit of some specialty items. On the cover here, it's going to show, here's our actuating devices if we're using quiet latch retraction, but we're not using quiet latch retraction. So now we're going to come down into the 900 4RL board. So on our instructions here, if you thumb through these instructions, this is for our 900 board here, and these are all the outputs and the different things that it does here. You just notice the auto operator, and we have the electronic latch piece here. Well, all we're doing is we're replacing the electronic latch piece with a strike. So instead of this panic bar device, we're going to have our strike sitting here. Notice you can wire in access door control with this and everything. In this section here, we're actually going to wire our BEA device. have yet another set of instructions that we can pull out and take a look at. So here is our receiver for our BEA. All right, so as we're wiring all this stuff together, we can look here and see, here's our wiring diagram for what we're actually going to do. So here's the power supply. Again, Schlage, LCN, they come across these really, they kind of build everything for you in these manuals, so definitely take a look. Access control for device 1. We can actually add a second operator to this if we wanted to, or if we wanted two separate, like a folding door or something like that, we could then coordinate it through here. So right here where it says access control for device 1, this is where this BEA device is going to plug in at. Now on the BEA instruction manuals, and this is where you kind of have to piece all these things together, decide exactly what you're going to do now so you know how many wires you're running in different places. On this here, we have a common, normally open and normally closed. So the common would be like your ground wire, and then normally open and normally closed. It's the state that the relay is in. So if we look at a relay and we have our common here, our ground here, then over here is a positive, right? We have positive energy running here. So this tag up here is normally open, this one here is normally closed. So that light switch or that link is closed here. And when we actuate something and this relay kicks, if power is being sent here, but say there's nothing attached on this side over here, then energy is constantly going through the normally closed section. Energy stops with the normally open. So if we wire this thing correctly, when the button is pressed, this is going to latch open and energy is going to flow, or it's going to notice a contact through there. So that contact closes and it tells the power supply, hey, we need to activate this relay over here now to activate this latch, and then we're going to send another pulse over to the operator to tell it to open.
So the sequence of what gets powered when is going to be whether or not we have a successful open. It has to open the latch first, correct, and then say, okay, operator, now it's time to do your job. Now you can open the door.
Yes. But how do you do that with all of these different instructions? Because if we look here, we see these two legs coming off to the operator over here, but notice it doesn't tell us, like this just says auto operator, it doesn't give us this piece over here. So here's what I like to do.
Is that because we could be running several different operators off of it?
Yeah, we can take any number of operators and run this through. So fortunately, boxes are awesome, and we can just drop a quick little diagram on here of how this stuff's going to run. Or we can just notate in here. These two wires for C2 and NO2, so this is a common 2 and then normally open 2. If we just take these two wires here, right, we just take this and we come over here to our wireless receiver here. So in this situation here, it's giving us 24 volt out. So really we can just annotate here. We're not going to use this, okay? We're just getting rid of all of this essentially, okay? Now, our common and actuate, this is what we're going to tie into. So number 4 and number 5. Okay. Notice over here the normally open and common was listed on our piece of paper. Now we're going to come over here, and on our sheet of paper here it's going to go to C2 and NO2. So C2 and NO2. Okay. And now we know, now we've linked these two documents together essentially. So over here I can write
C2 and NO, this is normally open.
That's yes, NO is normally open.
Okay.
So over here I can say on the operator side of things, I need positions 3 and 5. Excuse me, 4 and 5 set. So, because position 3 here is 12 volt DC out, or
right,
24 volt DC out, so it's powering something. We're not going to use this. It's just going to be left blank on the operator side, and we're coming in with common on 4 and normally open on 5 to our wireless receiver. This is actually going to now be our power supply relay board. This coordinates the actions. When it senses something here, when it senses the BEA device over here, Okay, and we're going to have the normally open and common here.
That's this,
That's
and
this
this
device.
is what's going to actually sense when a button is pushed.
Yep, so when we push one of our buttons and it sends a signal over. Yep, so when we hit our button here, it's going to send a signal to here. It's going to light up. It's going to, and you can see here, it's annotated where we have normally open and normally closed, so green and yellow. So even if we wanted to annotate that on here, we go green and yellow. So this SC and 11 actuate together. All right, ignore all these other lines because we're not utilizing any of this right here. We're just focused on the operator and this piece here, and this one here and ground. So this is going to be where I'm just going to draw a couple lines over here, and we're going to go strike.
Now, if we take the time and plan out our map right here, that's going to give us a whole lot better install, right?
Yes.
We're going to be able to map everything out in the instructions, draw it on a piece of paper, draw it right on the instructions right here. That's going to give you a map. It's almost like if you were trying to compare it to rekeying a lock or adding master keys, you would write all that sequence out so that you know exactly what you're going to be doing as you put it in there, and there's less chance of error.
Exactly, less chance of error, and we know, do we need 4 wires going over here, or do we need 6 wires going over to our operator? Right now, we only need 4. We have 2 for power, and then we have another set for the actual actuator, sending over that signal on when that operator needs to engage.
Cool. Some good heavy-duty wall anchors.
Yes.
Several different kinds. This is what we're using for this application.
So another handy tool to have is an extended drill bit. So this nice bit here allows me to go into the case and not actually hit anything. Standard length.
See that again?
Standard length bit, you're going to come in, your drills, you're going to be kind of funky on here. This just allows me to go anywhere I want in this case without the rest of the drill hitting anything important. So as you see, we just rested this on here, makes it nice and level, makes it square with the door. And then we're just going to fill All right, so on our operator here, this little block does pop out. So what I'm going to do is I'm going to find position 1, and I'm just going to mark it with my marker here. So I know where position 1 is. So here's our position 1. I'm just going to give that a nice little black mark on there, and it goes 1 through 9. And then we're going to detach this thing very carefully. It can be sensitive. If you take this thing off incorrectly, you will break off one of these things. So just make sure when you're removing this not to twist it. This thing will snap. All right, now we're going to refer to our little wiring diagram here, and we're using the power, and we're using positions 4 and 5. So what that tells me is for our external power supply and our feed coming in to initiate the motor on this, we're just using a 4-wire conductor. And here is our 18-4. So very careful. Anytime you're using razor knives or any other knives with this thing, you're going to want to score the outside of the cable and then bend it. Just scoring it a little bit with a super sharp knife is going to be enough to get it going, and then you just kind of flex it around and it comes right off.
If you try and cut it all the way around, you chance cutting into the other wires and then causing a short.
Right, so even after you're done scoring it, you just bend the wire and just make sure that you do not see any type of mark on the wire. If you see any metal showing through here, cut it, move down, strip it back a little further. You notice I have like 3 feet of wire sitting here. There's a reason for that, is because sometimes you mess up more than once. So we're going to remove this stuff here. This helps stabilize the wire when you're pulling it through longer runs. So if we're mounting this thing 30 or 40 feet from the power supply, we have to go up and down a couple walls. This fuzzy stuff helps with that. Okay, next we're going to pull out our wire strippers. And we're just going to use the very common colors here. We're going to use red and black for our power, and we're going to use white and green for our contacts. So these will be dry contacts. The difference between a wet contact and a dry contact is power and what one does not. Put these back a little bit. You don't need very much. The idea is to be able to insert this fully without wire showing. So if wire is showing out about that far, you need to trim down this wire a bit. If it goes in so far that the case of the wire is now in contact with these little guys in here, I'll close this gate so you can see. But if you take a look inside here, there's that little glint of metal. I don't know if you can see that in here. Yep. Okay, so that little glint of metal. That little piece of metal there is actually what's making contact with our copper wire. If it doesn't make contact with it, instead it clamps down around the plastic here, it's not going to get power, it's not going to get continuity. So, number 1, if we look at our diagram here, is our positive. Number 2 is going to be the negative for the power supply. Okay, strip these guys back a little bit here. So see, I know already I've stripped this back a little too short. We want about not that much on there, so I'm going to take a little bit more off. All right, everything's opened up here. So now we are just going to go ahead and insert our wires, tighten them down.
Really shows how nice that block removal is for this. So you
Yes.
can do it down in front of your face while you're looking at the wiring diagram, and then plug it back in. You're not standing on your head with your head all sideways trying to get it inside the...
And if you look at how this is set up in here, the reason the block removal is important is because these screws are facing down. It'd be nearly impossible to get a screwdriver angled just right in there without stripping something out. Block removal has to happen. It's a kind of a must. So, and then you just look as you're going along here. So you see if the wire is showing a little bit inside the gate here, that's okay. It's when it's clear outside here like this, it causes shorts. So we want to put it down in there just so we can see a little glint of metal as we lock this stuff down. All right, there's position 1 and 2, and now we're after 4 and 5. If I hook this up to 3 and 4, that's going to energize this line, and we don't want that. So we're going 4 and 5. According to this, 4 is supposed to be common, so we're going to use green for the common and white for the normally open circuit. All right, gonna make sure these are all nice and snug.
Snug, not stripped.
Yep, snug, not stripped. Pull on everything. Make sure it's in there nice and tight. If you're able to pull something out, now you got to loosen it back up, stick it back in there, tighten it back down.
Better to find out now than later after this thing's already working, and then it's going to cause you a warranty call later.
Exactly. So once we have our power and our actuator, now we have to wire in the, according to here, we have a fire jumper. So if this was on a fire application where the fire, maybe the fire alarm people are going to come in and wire, instead of this jumper being here, it's actually going to be a box that sits out here. You can see that down in this this diagram here. This is how the fire alarm relay is stuck in there. So now we need to make a jumper. And to do that, we're actually going to use some wire we have laying around. So over here, normally closed is yellow, so I'm just going to steal a chunk of this so we're not wasting too much wire. The jumper is just for continuity. No energy should be rolling through it. So we're just going to simply make our little jumper like so.
See that?
We're also going to grab our motor switch here and get it ready. We're just going to clip it here. May not be the exact spot it's going to be lining up in. All right, and our jumper relay goes from 6 and 9. So 6 to 9, 7 and 8 is for the motor switch. So we're going to slide this guy into 6. Alright, and our motor switch here is simply nothing more than dry contacts again. So we are, doesn't really matter which direction these go in. You can see here, these are cut a little bit, they're almost perfect in there. So you can see that glint of metal. So we're actually going to trim this down a tiny bit. Don't want any errors. So take a little 1/8 off there. So
Little haircut.
yep, little haircut. And slide these in here.
Now, for guys that don't do a lot of wiring, would just about any competent low voltage person be able to follow these directions?
I believe so. Depends on where you're finding your competent work. I would find somebody who's experienced with cutting wires, maybe an electrician. In areas where you have to have a license to do this stuff, you have a little bit of extra education. Regardless, you need to make sure you understand basic low voltage concepts as a business owner and as someone that is going to come back and troubleshoot these things. You need to know how all this is wired, how it's supposed to look.
Okay, so let's just take a look at that thing before we get too far here. Now you're basically just going to plug it back in?
That's it. So I like to take a picture of all of my installations along the way. So, and if the customer ever calls, especially with this, we're actually wiring this one up a little bit different here than we normally would, just because of the extra pieces. So we're going to gently plug our device in the correct way here. Again, don't strain this when you're putting it in. Make sure your wire isn't super tight back here. You're going to leave just enough so it's a little loose. Be careful when you're letting stuff dangle. Now, our box is going to slide on this direction here, so our switch is actually mounted in this downward position here. This turns the motor on and off. So this has nothing to do with the key switch activation over here. So as far as like the strike assembly, this has nothing to do. This just turns this motor off. So everything that's happening over in the power supply here when you push the button happens no matter what. This just turns the motor on and off whether the door swings open or not. So I believe we actually have enough little room, a bit of room behind this. Hide that wire back there a little bit. I'm always looking for different ways to hide the wire and make sure that we contain everything as much as possible.
Just make it as idiot-proof as possible so that when somebody comes by here and pulls the cover off and tries to do maintenance or tries to adjust this, that when they put things back together, they're not pinching wires.
Exactly. And again, documenting everything. We want to make sure that we have clear pictures of all of the things we're doing. As we're doing them is good, then we can identify any mistakes if we make them.
Cool.
Okay, so now we're going to mount in our BEA device here. We're just going to select a good place here, put something somewhere, right? So we're going to take our little Velcro pieces. I like to make sure that like the hook side and the soft side there is one or the other needs to be on the device. And then
Literally just sticks on.
that's it. So you just peel these off, stick them on. Go from there. If you're going a long distance with your transmitter, you're going to make sure your cord is maybe sticking outside of this metal box. It's going to shield some things. 900 megahertz, the RD 900 is what we're putting in. It's a 900 megahertz receiver. It's going to go through a lot of materials. So you'd have to mount these things pretty far out before that 900 megahertz signal was interrupted. So we're going to mount our device right here.
It's better to go larger than what you think you need rather than go hook it up. Doesn't work.
Exactly.
You needed a bigger one. Oops.
Yep. So 900 megahertz, just different frequencies. Maybe you have a lot of 900 megahertz devices in the area, go 433. If you have a bunch of 433, go 900. Just pick one or the other. If we were putting batteries in here, because this does allow for a battery backup to be hooked up here, we would actually want to mount this up here. We're going to have a lot of stuff going on here, so this will be a good way for us to show how all the cables and everything are going through. Another important thing with this power supply, this has a 2 amp, 12 or 24 volt DC. It is selectable. This instruction sheet here, or the instructions that come with it, are going to tell you how to select that. Right here on the board, use jumper to select 24 volts or 12 volts. It comes factory standard at 12 volts on this deal here. We just bought this from the factory. Came factory standard 24. If I wanted to go 12, I just jump this down here, and now I'm at 12 volt. You want to make sure that this is done before AC power is connected. If you do this in the middle, more than likely you're going to short something out. So you make sure to make all of your power adjustments here before your electrician pops in and does anything. So, and again, this jumper cable coming from the power supply board down to our subboard here, super handy. That means I don't have to mess with any of these contacts, any of this stuff over here. I'm just working on this. It'll give me my wet outputs here, dry outputs, whatever I want here. There's a bunch of little jumpers inside here as well, and you will refer to the instruction manuals on what all these jumpers do from the factory. This should be fine. But you can even see here too, where we have a dry contact and a powered contact. It appears here that the powered contact or wet output is selected by default on this board.
Okay, and one more thing that I really noticed that I like is you write the date and the voltage that you've selected.
Yes. When I open this up later, I don't want to have to go hunting around on the board for, well, did I do 12 or 24 volt? I just write 24 volt here. I put my installation date. Sometimes I'll sign this when we're done, slap a sticker in here. We put this thing in, and maybe my warranty is if someone comes in and works on it, it's the warranty may become void if someone else works on it here.
Perfect.
What we're going to do is we are going to loosen up our power terminals over here. It's always good to do this when the power supply is off as far as initial wiring. You can do it while the power supply is live. Say you wanted all this stuff set up first and then power. You can work on these things live. It's just you have to be really, really careful on what you're doing with them. So for these,
Much better to do it while it's before it even gets power applied.
Exactly. Then you're not, the chances of shorting something out are a lot less. So our receiver here needs constant 24 volts to run. So we're going to come out of the constant terminal here and hook our power up to our receiver. Because we're going to work with wet outputs over here or power outputs here, and to power our lock and our and everything else, we're going to run that. While we are talking about this being powered, we're also going to run constant power over to our device. So here's kind of the way I measure wire, right? I figure this is about what I need, and then I add about 3 inches. Scissors are super handy. A lot safer to work with than trying to take this razor knife or a big knife and try and cut this. So we're going to cut quite a bit off of here because we have to run the wire a little bit different. So another good reason for this stuff is instead of trying to take your razor wire and run down the cord here and wind up cutting yourself, just take this, kind of measure out relative what we need. We're going to take this little guy and we're just going to pull on him, and it's going to strip our casing back here. So we're going to come back here, clip this off, get rid of that. And then what we're going to do is we're going to open this case up like so. Cut our case back here. Always handy to have a trash can nearby. And we're going to separate our wires. All right, obviously, our contact wires here that are coming to our board don't need to be this long, but we do need these kind of longer wires for our power. So I like to make sure that as I run stuff in here, it looks neat, it's straight, it's direct on where things need to go. And we don't have a giant coil of wire sitting in here. If you do want excess wire, if you're planning on moving the power supply later, or you think that's going to happen, we can always dump a little extra wire into the wall here. That's fine. You can make a little coil in here if you want to. This is going to be a pretty standard setup, right? So we're not going to be moving this box around. You could plan for those things if that's going to happen, but usually when these go in like this, it's a permanent mount. So I'm just going to plan out our wire roughly here. Again, you can always remove wire. You can't really add it back later without splicing. So if you do make a mistake, cut something too short, you can splice it in. It's just not going to look as pretty. Okay. You can also mount like a power distribution block if you have more. If you have like 6 or 7 different pieces coming in to pull off the power supply, you could use a higher rated output here, or a block in here to attach everything to. So you have a single set of wires coming out and then multiple hookups. So our positive is going to be red, negative is going to be black. And then in here, you'll see, remove this here so you can see a little closer. So our terminal block here, there's our screw. And you notice this little plate here. So that little plate around the screw, the little washer, we're going to run the wire underneath here, and then you'll see this other metal plate sitting here. It's going to mush the wire between those two plates, and that's going to help give us a really good solid contact in here. If that plate wasn't there, we could simply add a little connector to make sure that it makes good solid contact with the screw and terminal. So we're just going to run that wire in like so. And then the same basic concept with our, like here with our terminal block, we want to make sure that the case goes, this sheathing here goes to the bottom of that plate, but not underneath it. It would make a bad contact. When I tug on our contacts gently to make sure that they're in there good, right? You don't want to over tighten this. You just want to give it just snug enough to keep it in there. We don't want wire poking out the top. If you have wire poking out the top, obviously there's stuff up here it can touch, and once that stuff arcs, it blows something up, and then it's game over for the power supply. Once they short, they're shorted out forever. Or once you release the smoke out of them that they put in all those components, when that smoke comes out, it's just game over. So same thing with our negative terminal. Slide that in like so. You'll notice I'm putting one wire on one side, one wire on the other. You can do it however you'd like, as long as the connections are made. Cinch it down, little tug. Notice on this one, it's coming above the screw a little bit there. That's okay as long as it's within these terminal blocks. If it sticks out the top further, then you know you've got a bad termination.
Cool.
All right, so we're gonna take our other diagram. So we figured out on our power supply, on our operator side, excuse me, on how it ties into the power supply. Now we're gonna take this power supply wiring diagram up with us. Okay, and grab some tape here, tape it up here so that we can see what we're doing. Okay, so all that pre-planning, wiring and everything should be fairly simple right now and straightforward. So our wire here won't exceed this length, so we're just going to trim that off. This is for our lock, it's our 18-2 wire. Okay, so now we're just going to come in and take a look here. We need to select the device we're going to work on first. At the top, we're just going to come straight down. So our actuator, or operator, is going to go first. This NC2 and C2, like on this side over here. So we're going to go C2 and NO2, that's what we're after. So up on this block here, these blocks don't come out, they're attached to the board permanently. And on the side here, you'll note that it has the different readouts on the different levels. So level in here, there's this lower bank and this upper bank, they're listed down here. So our ground, let's take, so we're just going to make our adjustment here. So getting the right tool too, this is a little bit wider flathead screwdriver. we're able to come in and grab a hold of these screws a little bit better. Over on the other thing, we had to use a smaller one. Bigger the better, gives you more torque on these bigger screws. So it's not one screwdriver rules everything. And if you can't read the tiny writing on the board, because it is kind of stamped in there, this block diagram is mirrored. So on the left side here, and the right side, left side block, right side block. Same principle with the other thing, you just want to make sure the wire goes in just deep enough for the gate to grab onto it without grabbing onto your wire mold around the outside here, but not so far out where it's able to interact with other wires. Make sure they're snug. Give it a little tug test to make sure it's in there nice and snug. Without if you over tighten these, it'll just chop the wire off. So
You'll literally just crush it?
It'll crush it, it'll just smash it, cut right through it. So on our diagram here, we're not going to use that one, this one, that one, and so we just mark on our wire what we're actually using here, what we're doing. Pause. All right, so as we're just drilling down here, figured out what we're using, our next is going to actually be our latch. So we're going to come around here with our wire. We're going to kind of try to follow the same wire path as everything else is. So we are coming to two kind of different locations here. So what you can do is mark off like we are not using this one. So just put a mark, kind of a black mark on here. We're not using that. And let's see, we're not using this one. Okay. Just kind of mark out what you're not going to use. Kind of helps give you a position on the board on what you're doing. So we're going to come here from the N01 on the board, and this is normally open one. This is going to be for our strike. The strike is a normally open strike. It means it requires power to actuate. So normally open. It doesn't have power. Fail secure, however you want to word all that. It is a fail secure device. When there's no power applied, it is in the locked position.
But we do have egress out.
Correct. Orientation is going to be important on this too. N01, that doesn't tell us on here whether this is powered, not powered. However, ground is usually our, right? So this is our ground. So N01 must mean our positive energy, or the positive side of our energy is going to be pushing out there. So we're going to hook the red contact up to that, the red wire up to that contact. Now in some applications where we have a single door, maybe it has two leaves on it, and you have two panic bars on it, you're going to have two red wires coming out of this slot, two blacks coming out of here. So in that case, especially if you're using a larger gauge wire, like 18 gauge, 1, 2 might go into there, maybe. That's why you may come out and use a relay block. So look for options. If you can't get the wire into the hole, look for another option. In that case, it would be another block similar to this, maybe with some larger terminals. All right, contact is wired in. Now we're going to wire in our receiver here. So it's just simply these two wires. Again, these are dry. This is considered dry contacts coming in. It's just hey, we have signal coming here. It's either opened or closed. I'm telling the board what to do. All right, so we've got everything wired in here. I use this Velcro stuff. You can buy Velcro by the roll, which is awesome. Clip off what you need. Make sure everything looks nice and pretty. On the board here, we have some dip switches. Make sure you read all of your instructions. Yeah, here it says summary of operation, right? Latch motor, LX triggers auto operator, right? If we're using a panic bar device, but we're not using one, so what do we do there? Well, right down here, single door board configuration. Position jumpers for dry contact for outputs 2 and 4, see page 2, right? Turn on switches 5 and 6 on SW1, 6-second time delay.
Okay.
If LX is not used, turn number 1 on. So we make sure this diagram over here does not actually show specifically what we're supposed to do, because this here it says switch 1, over here switch 1 is actually turned off and switch 2 is turned on. So we've turned off switch 2 and on switch 1 according to this. We'll know if it's accurate or not. Maybe switch 2 is supposed to be on, so we'll figure that out once we power the board up. If something doesn't work correctly, then we know what's going on. So keep in mind all this information here.
Cool, thank you.
Getting down to the strike installation. Again, 24 volt power supply, get your 24 volt pigtail for your strike here. Again, just scoring the outside of this. Okay. Peel back a little bit here, cut this little fluffy stuff off. On this, you're going to want to strip back the wire a bit more than you have anywhere else. Okay. Same thing on your tails here. Strip this back. Good and far. Make sure you have yourself a pair of, what are these?
Lineman's pliers.
Lineman's pliers. I like these a lot.
Fencing pliers.
Yep. So what we're going to do now is the box is going to come with these. I just throw all of these little beans into a bag. These are dolphins. These ones have some gel inside of them. It'll coat the wire and help with corrosion. If you're putting this into like an outdoor application, these are really good.
Keep moisture and stuff out of the connection.
Yeah, it just keeps that moisture out. Also helps with the conductivity a little bit. So we're going to slide this on here until it hits the end.
Beans, dolphins, yellow jackets, all the same thing.
The beans, some of these do not come with that gel inside of them. I like the gel inside there just because it
It's
adds a little extra protection to it.
Specified as a weather resistant option, right?
It is, or like in this application, again, it just helps with that conductivity a little bit, keeps it going.
Yep.
So inside here is a it's like a steel piece, and then it has like a fiber, like a copper mesh kind of stuff sitting in there to clamp the wires together.
Yeah.
Put those on nice and snug.
If you've ever taken apart a connection and it's kind of dry and got a bunch of nasty, crusty stuff in there, it's because it did not have that jelly.
Exactly. Get the other hooked up.
Let's see what that looks like.
After you get that stuff hooked up, I like to take some tape, or you can get some shrink wrap, whatever you guys want to put on here. I just take my connections like so. See, I cut it nice and flat there. I couldn't find it. All right, I start from here, and then I just simply wrap up these connections with tape. What we're doing is we're putting insulation back into the system here. Like these wires have some insulation here, we pulled it open here. This wire has thicker insulation. We just want to protect our wires as much as possible. So, down like so.
It's like putting them back in the jacket.
Exactly. I'm just putting a little bit of protection around them because we're going to put it back in here where we drilled, and now they're sharp metal.
Now, I know you like to use that red tape. Does that help you distinguish whether or not you were here last or whether or not somebody else has been working on your stuff?
It just is my favorite color.
Got it.
Red tape is rarely available anywhere, so can't really say whether this was my work or not, which is why I take photos. Then if I ever come back here and say wire nuts are on here, I can say, yeah, we use these beans or these dolphins. So again, pulling out the phone.
Take pictures of your work, attach it to the file when you send the customer. I also have them organized in a file folder in Cloud, and they have time and date stamps, so that way I can come back and find them when we need them. Hopefully we don't.
And this little program we're using here actually puts the time and date right on the photo. So if I come back into this photo, it has the time and date stamp right down here, the exact time and date. So I use military time, 1658.
Cool.
Off it goes. So, going to,
If it's an outdoor connection, is there some kind of jelly stuff that goes in there?
there's no gel in here, right? There's no jelly stuff in here, and the manufacturer didn't send any with it.
Okay.
So this is not like an outdoor rated contact. If you put this into an outdoor environment, you definitely want to, what I typically do is I'll actually have some heat shrink. We'll heat shrink this together and make it as watertight as possible, and then we'll use more tape.
Cool.
So,
But we're on indoor application here, so not relevant.
exactly. I do take some tape though and tape this connector together in case, so it just kind of locks that thing down. Right? Again, we're protecting our wire when we do this, so when we have to take this back out of the door, as we're pulling the wire out, because this wire hooks up into a little 1/2-inch hole, and it has sharp pieces on it. We want to eliminate any problems ahead of time. So making a jacket for this is going to be important. If the tape becomes nicked, that's okay. If we nick this wire, it's kind of over. Then we're making another connection. If you do say this gets nicked or cut, you can come back in here, see where these wires go through. There's a wiring diagram you can look up and see what wires are connected together to make 12 or 24 volt on here. So again, you can use heat shrink. Tape's inexpensive.
Just giving those wires just a little bit of extra protection. That way when you do come by and yank this thing out of here, look at it, check on it, whatever you're trying to do diagnostics on it later, it's all protected.
That's exactly it. So, and I'm just going to stick this connector up out of the way just enough to clear this box, and then we can run our wire kind of down the side over here a bit. This pocket's pretty big, and there we are. So pull this back out here, and you can see this connector is stuck now, right? So it's going to take a little bit to get that out of there, which is why we put the tape on there. Make sure everything's nice and insulated. So
Good.
now we're going to be able to take our wire though, kind of tuck it to the side. Some of these boxes are smaller, you have to cut them out of the way. This one is pretty nice.
That fits absolutely perfect and flat. I like that.
So now all we're going to do next is we're going to notch out here. I like to take a marker and just fill out.
That's for the dead latch.
That's for the dead latch, yes. The ramp here, the dead latches, most of them will sit a little bit deeper, so that dead latch, as it sticks in here, it hits this, catches, and gets in the way. So another portion of the evaluation of the door, if you want to step out here, it's really important to make sure that we have the right tolerances in place. We want to make sure we have, at minimum, the minimum number of amount of gap here should be about 1/8 of an inch. A little bit more is better. So 3/16, 1/4, something like that is going to be better. As this thing opens, when this latch releases, this little catch in here. Here's our dead latch here that rides up the ramp. But as our catch here, as our latch opens here, as the door is pulled open, if there's not enough clearance between the strike plate on the door, the edge of the door itself, the latch, this piece is going to drop out of the way, but it's not going to drop out of the way enough for that latch to ride out on this ramp. So you want to make sure, you're going to notch it here, but if there's not enough clearance between the edge of the door and the jamb here, it is going to catch on the gate here.
Okay.
Make sense?
Yep.
Did I explain that good? Okay. Alright, so we're going to take our rotary tool here, and we're going to find the middle of this piece, and we're just going to zip in about 1/4 of an inch. Take our file. Make sure there's no super sharp edges here.
All right, so we've got a problem here where this is actually not engaging properly. It's not allowing it to go in far enough. So you can see that we're actually hanging up on the portion as it tries to slide into here. So what's going to solve that? This is the real world, and this is the difference between a pristine in work environment and actually doing this out in the real world. This is a real job. So we're going to have to use our hinge doctors on that side. It's going to pull the hinge up and over, and if you notice, we are hanging down just a little bit in there as well. Okay, let's see if we can really get a good close-up of that. Okay, so you can see right where it's hanging there, and that's hanging way down at the bottom, right here. Okay, so hopefully this will pull that up. Here we are, all installed, and then you can see we've got that little bit cut out right in here. Fairly difficult to see from this angle, but right there. When I do these hinge doctors, I actually put the airbags in here, forces the door all the way up and over as much as possible. Then you've got your hinge doctor, use a big wrench, take the slack out of it, never adjust the bottom one, only the top one, possibly the middle. We can easily see that this is resting much more in the middle than it was before, and we should get a good close on it. Beautiful.
All right, so now we're just going to set the opening on our door here. So on the top of our panel, we have a calibration button. Ensure the door is closed. So it needs to be all the way closed. We're going to press the calibration button twice, and then we're going to move the door to where we want it to open to. So, gives us 2 flashes there, 2 beeps. And open the door to where we want it open to. It's going to beep again. We're going to let the door close. And for testing purposes, we have our button sitting down here. It's synced up with our operator.
How did we test this out? We actually had an electrician wire in our pigtail here so that we can plug it into an extension cord so that we can verify that everything's operating for this video.
And then after we're done, they'll come follow up and they'll go ahead and they'll hardwire it in with some conduit and bring 120 volt power into it. Alrighty, anything else we need to know about this?
We're going to put our little covers on. Take our cover here. Slide that little guy on there. Grab out of our screw kit here our cover screws. These ones don't have any real torque requirement. Got the little LCN tool here. We'll fit these screws as well. Take our cover, slide it on, make sure that your switch here is where it needs to be. And these screws just thread into the standard cover hole screws. Off and running.
Beautiful. Alrighty.
On the standard installation, if we turn this off, now if we hit our button, the stuff does actuate, the door unlocks, the motor just doesn't move. So if you are in a more secure environment, you're going to want to put in some type of disconnect for the power coming in here. So it can be something as simple as wiring in between the BEA device and maybe adding in a switch or something in here, a key switch, whatever you want, so that even if a button is pressed, it's going to actuate, but no signal is going to go to the rest of the system. So if you're in a more secure environment where maybe you have a locked handle, you're able to make sure the space stays secured. Otherwise, if you just click this motor off and you hit the actuator, you're still going to be able to open the door with no problem.
It's sending power to the latch, and because we don't have a credential reader or some kind of a reader on the outside, a reader on the outside would also solve the problem, correct? If you wired it in, so that way you've got a badge in, or do your fingerprint, or do whatever your credential is or your number, then that's going to allow it permission to unlock the strike and operate the operator.
Right.
Many ways to solve that problem.
Exactly. And that key switch, little switch in here, or even just turning off the power to the power supply and wire up like an out, like a standard wall switch or something over here.
For our application here, just setting up a switch is probably going to be the easiest way to go, because this is basically kind of like a public conference room when people are using it, and then when they're not using it, it requires, the way that it's set up now, it requires a hard key for the staff to come in through that door, because this will be powered completely off. They'll do their hard key. It's a storeroom function lock. They come in, they turn the power onto the device. That allows access for the day. The people come, they go. When they go to shut this room down, they go ahead and turn the power off. Now it's completely secured again. It requires a key the next day. Thanks, John. Appreciate it, and we'll see you on the next one. Very important to make sure that we have a automatic caution door sign. That is actually going to be part of the ADA requirements when you have an automatic door operator, that sign can clearly be seen from both sides of the door, so that nobody gets hit by it, or if they do, they're at least aware that that is an automatic door. Alrighty, now we're going to mount the buttons, or the activation buttons. These come with some regular screws, drywall screws, wood screws, or you can use self-tapping metal screws. Basically, you're just bolting the housing onto a solid piece of wall or a stud behind it. Make sure that you're not just putting it in directly to a drywall. Kids and stuff will come by and they'll rip it right off the wall. Here's what our installation looks like, all clean and done. We could recess this box in. We can do a lot of different things to clean it up. We could also run the box all the way up above the ceiling if they don't want to see it. However, for a donation, I think this was a pretty good, clean install, and they're extremely happy with it. For more information, please scan the QR code. We cover topics on electronic access of all kinds at Wayne's Lock Shop and Lock Reference.